Let's have the discriminant. What is this discriminant class? The discriminant of the quadratic equation is that b squared minus 4ac inside the square root symbol. What is the use of that discriminant method? This b squared minus 4ac is used to check whether we have one solution only or two solutions, or if there is no real root of the quadratic equations. So we call this b squared minus 4ac discriminant. And the purpose of that one is this one. It tells us the number of solutions of our quadratic equation. If we substitute the value of b, a, and c here, and if we compute that one, and that is equal to 0, meaning we have the square root of 0, then there is only one solution for that quadratic equation. And our equation is a perfect square trinomial. Okay. If the b squared minus 4ac is greater than 0, it's 1, 2, 3, 4, 5, 6, then we have two solutions for the quadratic. Two solutions. Now, if this one is a perfect square number, like 1, 4, 9, 16, 25, 36, and so on and so forth, then we have the factoring. We can use the factoring method to find these two solutions, because this factoring is easier than using the quadratic formula. Okay. If this one is not the perfect square, then you may resort to quadratic formula. Now, if upon substitution of the b, a, c, and the result is a negative number here, if you put a negative there, then we don't have the square root of a negative number. Therefore, that quadratic equation has no real root. Okay, let's have an example of that. I'm going to erase this one to give us more space for our example. And let us have that one only, the discriminant there, so you will see the discriminant. I'm going to erase also this one here. So we have b squared minus 4ac. Okay, let's have the first example. Here it is, x squared minus 10x plus 25 is equal to 0. Okay, it is arranged already. Now let's find the a, b, and the c. A is equal to 1, b is equal to negative 10, and c is equal to positive 25. Now you will notice here, class, that this one is a perfect square trinomial. We have 10 divided by 2 is 5. 5 times 5 is 25. When you factor this one, you have x minus 5 times x minus 5. And our answer is 5. Only. There is only one solution. And let's prove that one by putting this one, the a, b, and c in our discriminant. So b, where's the b? Negative 10 squared that one, and then minus 4 times the a is 1, and our c here is 25. Negative 10 times negative 10 is 100. Then negative, there's only one negative here, it's minus 4 times 1, 4 times 25 is 100. So what is 100 minus 100? It's 0. Therefore, if that is 0, we have only one solution for this equation, and then when we solve it, we know that the answer there, or the solution there, is x is only 5. There is only one solution because this one is 0. Okay. Number 2, we have x squared plus 2x minus 3 is equal to 0. So our a here is equal to 1, b is equal to 2 here, and c is negative 3. So when we substitute this one in our discriminant, the b squared minus the 4 times the a times the c now is negative 3. So what this one? What is the result? Not yet. We have 2 times 2 is 4. Negative times negative here will give us positive. 4 times 3 is 12. And then 4 plus 12 is 16. And what is 16? 16 has a square root, and the square root of 16 is 4. So if this one is a perfect square, we have 2 solutions. Okay, like perfect square. 1, if this one is 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on and so forth. And we have a square root for that. Then we have 2 solutions for this. And not only 2 solutions, we can skip using the quadratic formula and use the factoring method, which is easier than using the quadratic formula when the result is a perfect square number, or a number that has a perfect, factor of the square root is exact. Here. Now, what if the number here is not exact? Example, we have 2, we have 3, we have 5, like that one, 21, 22, 23, 24, 26. If you don't have a perfect square number here, then we resort to quadratic formula. This one is used only when we can factor. If not, it's quadratic formula. Because if you are going to factor this one is easy. X, this one is 3, and x minus 1. 3 times negative 1 is negative 3. 3x minus 1x is 2x. So our answer here is we have negative 3 and x is equal to positive 1. You see? This one is easier. Factoring is easier than using the quadratic formula, because in the quadratic formula, it's a very long method. Okay, number 3. So for number 3, we have x squared minus 5x plus 10 is equal to 0. So what is the a here? It is arranged already. A is equal to 1, b is equal to negative 5, and c is equal to 10. Alright, b is negative 5 squared minus 4 times a times c. Negative 5 times negative 5 is 25. Negative, there is only one negative. 4 times 10, it's 40. When we add this one, it gives us negative 15. When the sign is negative, it means it's less than 0, then we don't have solutions for this equation. And then we say that there is no real root for this equation.